So for our module 2, which is basic aerodynamic principles, part 1 pa lang. So part 1 tong module number 2. So yung part 2 ng basic aerodynamic principles will be on midterm na. So, for our part 1 video, we will discuss the continuity equation in compressible and compressible flows, and momentum equation, and then the Bernoulli's principle for incompressible flow. Then, sa part 2 ng ating video, ay ng discussion, we will have the compressible flow, and then the isentropic relationship, also the energy equation. And for our last part, in part 3 ng ating discussion will be the speed of sound and wind tunnels, including the low subsonic and supersonic wind tunnels. So for our first topic, we have the continuity equation. For continuity equation, punta kayo sa page number 5 ng inyong module 2 para masabayan nyo ko, or may makasunod kayo dito sa discussion. So for page number 5, we have the continuity equation, which is from the physical principle of law of conservation of mass, which states that the mass can be neither created nor destroyed, wherein meaning if you have here a duct, and if you see this, tapos we have kunyari a substance flowing or entering this tube na lang, parang tube siya, pero parang funnel. So if you're gonna enter, if a substance is going to enter here sa tube, and that substance, or let's say water, has mass, and then kapag dumaan siya dito sa tube, then lumabas man siya, that mass will be the same. So yun yung sinasabi na continuity equation ay na law of conservation of mass. So yan, as you can see dun sa figure number 1 ng inyong module, we have a streamline na kung saan this is our point 1 and this is our point 2. Okay, sa point 1, sabi doon meron tayong area, velocity, and then the density for that specific substance as it enters here sa streamline na to. So this area will be area sub 1 dahil nasa point 1 siya, and then velocity sub 1, and then density sub 1. And same goes with this part sa point 2. We have area nalalabas, we have area, we have velocity and density. Since nasa point 2, we have area 1 and velocity, area 1, area 2, velocity 2, and density 2. So yun nga, sabi dun sa law of conservation of mass can neither be created nor destroyed. So we have here a mass, then what enters here will be the same as it leaves the system. So we have a mass, and then this symbol represents the what we call mass flow rate. Simply, so that mass flow rate, simply this mass flow rate is a rate of the mass. So mass flow rate, wherein ang unit ng mass flow rate is kilogram per second, or slugs per second, or pound mass per second. So, di ba pag rate, ano siya? over change in time. Kaya, yun. Meron ka lang second sa ilalim or kahit anong time like minute or hour. Anyway, that is our mass flow rate. Wherein our mass flow rate have a formula na mass flow rate is equals to density times area times velocity. So, here sa page number 5, nakuha lang natin yung formula for, dinerive lang niya yung formula for that. So, sa mass flow rate, check nyo na lang. So, hindi ko na i-discuss yung derivation. So, what's important is to know how will we use this formula. So, wherein this density is the density at that condition, at that point. And then this area is also the area at that point. And this velocity will be the velocity same at that point. So, hindi mo pwedeng gamitin yung area sa point 2 kung ang meron ka, kung ang ginamit mong density and velocity is sa point 1. So, because of the law of conservation of mass, wherein mass at point 1 is equals to mass at point 2, we will now have the formula for continuity equation, which will be, since mass flow rate is, wherein mass flow rate is density times area times velocity. Mass flow rate 1 is, at point 1 is density 1, area 1, and velocity 1. Then equal daw with the mass flow rate at point 2, which is density 2, area 2, and velocity 2. Now, this is the formula for the continuity equation, wherein this is again density, and at variable A is your area, and variable V, may arte, is your velocity. Take note of that. So, the unit again for our mass flow rate is kilogram per second or slugs per second or pound mass per second. And unit for density is kilogram per meter cube. Area is meter squared and velocity is meter per second. Then pagdating naman sa English, you have slugs per feet cube. Then area will be feet squared and velocity will be feet per second. So, paano nangyari yung cancellation naman yan? For this, paano natin nakuha tong kilogram per second? So, saan natin nilalagay? Here na lang. So, we have the density, area, and velocity. Now, the unit for density is this one. Let's try sa metric. Kilogram per meter cube. Then, times the unit for area, which is meter squared, and unit for velocity, which is meter per second. Then, we have meter squared times meter will be meter cube. So, meter cube sa taas, meter cube sa baba. This will be cancelled. Ang natira is kilogram per second. So, same goes with the English units. We have the slugs per feet cube as your unit for density, and then feet squared as your unit for area, and feet per second as your unit for velocity. Now, feet squared times feet is equal to feet cube. Then, therefore, magka-cancel yung feet sa taas dahil may feet cube ka sa baba. So, therefore, your unit for mass flow rate in English will be slugs per second. So, yan. Kung gusto nyo gawin siyang pound mass, i-convert nyo lang yung slugs to pound mass. So, yan. I would suggest that you always use the conversion table and SSLC that I've provided I will no longer accept the conversions that are found, hindi naman found, na sinearch nyo sa YouTube, sa Google. So, meron naman akong pinrovide na conversion, so gamitin nyo yan. And also, if naman nasa cycle naman yung conversion, I will accept it na lang. So, next. Another thing to take note here is that, for example, we have our point 1 that have density, area, and velocity 1. So, also here at point 2, meron rin siyang density, area, and velocity. Take note that it is said here in continuity equation, if your area is increasing, your velocity will decrease. And if your area is increasing, your velocity will mali. So, if your area is decreasing, area increasing, velocity decreasing, area decreasing, velocity increasing, or in other terms, area is inversely proportional to velocity. Yan. So, what else? Another thing to note, sa mga problems, we have the converging terms which are converging and diverging. If nabasa ninyo, or if it's stated that it is converging, therefore the area is decreasing. Then kapag diverging, area is increasing. So makikita niyo yan sa mga problems. Ang nakastate lang dun ay converging duct or converging tube, diverging duct or diverging tube. So if area is decreasing, like if this example here, let's see kung decreasing siya, or let's see if converging siya or diverging. So you have your area here, area at point 1 na mas maliit kaysa sa area at point 2. So what will that be? Area is from point 1, then lumaki siya sa point 2. Area is therefore increasing, therefore this duct or this tube is a diverging tube or duct. Next, converging naman, this will look like this one. So we're in your area at point 1 and area at point 2 nandiyan. So your area at point 1, as it moves, or as the substance flows here sa duct, your area is decreasing, therefore this duct is a converging duct. So converging to. I would like you to take note of that. Next will be the types of flows. So there are two types of flows, pero as it is stated in your page 5 sa inyong module number 2, all matter daw is compressible. So, pero there are times na kung saan your change in density is insignificant, or yung change in density mo is parang super small, that is considered negligible. So doon natin ma-identify kung aling type ng flow siya. So first, for incompressible flow, first thing to note is that here in incompressible flow, your fluid density is constant. What do we mean by constant? Your change in density is rather neglected. Sa super liit lang ng change ng density, like for example, your density at point 1 is 1.10, and then your density at point 2 is 1.00000000009 kilogram per meter cube. Super liit lang ng difference nila, which is 0.0000. Ewan ko kung ilang zero yung ginawa ko. Ito 1. So yung ganyan kaliit na density is considered neglected na here. So consider this flow an incompressible flow. So that is the first thing to note, the density or change in density. Next, we will look at the velocity. If the velocity is less than 100 meter per second, it is considered as incompressible flow. Kasi nga, here, pagdating sa less than 100 meter per second na velocity, yun rin, your change in density rin is super liit na. Okay? So, pag dito sa incompressible flow, we will look at the mass flow rate or our continuity equation. So you have your mass flow rate at 1 and mass flow rate at point 2. Therefore, we have your density, area, and velocity at point 1 and density, area, and velocity at point 2. Now, it is said that incompressible flow change in density is neglected or your density at point 1 and density at point 2 are equal. So if equal to, like for example, you have your density is equal to 0.5. So this 0.5 kilogram per meter cube will be put here. So may 0.5 pa dito. And then your density at point 2 is also 0.5 dahil nga incompressible flow. Therefore, magka-cancel na lang tong density mo dahil may 0.5 ka on both sides of the equation. So, your new formula ng continuity equation will be area 1 and velocity 1 is equals to area 2 and velocity 2, wherein this is the continuity equation for incompressible flow. Another thing to take note, if the mass flow rate is density, area, and velocity, if this is your mass flow rate na kung saan ang unit mo is kilogram per second, what will this be? This side of the equation, what will be your A and V? What is this called? So your A and V, if area and velocity, so if you look at its units, so area is meter squared times your velocity, which is meter per second, that will be meter cube per second. So ganun rin yung mangyayari for English. If your area is feet squared times your feet per second na unit for velocity, your unit will be feet cube per second. And we all know that any dimension for length na naka-cube, any unit ng length na naka-cube, it is a unit for volume. Therefore, this A and V, or area times velocity, is what we call the volume flow rate, wherein Q is the volume flow rate. So, again, rate na rin siya. Diba? Kasi nga may per second ka. Divided by second. So, again, let's see, kapag mass flow rate equal siya sa density times area times velocity, wherein your mass flow rate has a unit na kilogram per second or slugs per second. Pagdating naman sa incompressible flow, your density will be neglected. So, magka-cancel sa density. You will now only have the area and velocity. Then, this area and velocity of the one side of the equation, this area and velocity will be your volume flow rate, which has the unit of meter cube per second and feet cube per second. So that is for incompressible flow. So ayan, lagay natin si volume flow rate dyan lang, isin ko lang. That will be for incompressible flow. Next will be our compressible flow. So again, ang kinoconsider natin for the type of flows is the density and velocity. Now, kapag sa incompressible flow, density is neglected. Pagdating naman sa compressible flow, your density will be significant. Or change in density is significant, therefore your change in density is considered. Baliktad. So your change in density is significant, therefore your density is considered. And then another thing to note, that compressible flow, your velocity is more than 100 meter per second. Okay, now again, if your mass flow rate at point 1 is equals to mass flow rate at point 2, your formula for compressible flow continuity equation will be this one. Density, area, and velocity at point 1 is equal to density, area, and velocity at point 2. Wala ka nang ika-cancel dyan dahil nga yung density or change in density mo is now considered. Again, this density, area, and velocity is what we call the mass flow rate. So these are the things that you need to consider. These two flows discuss natin or ma-encounter natin here sa module number 2. Okay, next topic na tayo. So before pala tayo mag-proceed sa next topic, we will answer this sample problem. So we have a liquid that flows through a pipe with a diameter na 10 meters at a velocity of 900 cm per second. If the velocity increases to 2,500 cm per second at a point on the pipe, what will be the area at that point? So let's see, we have your area at our first point, which is said that through a pipe may diameter ka na 10 meters. So diameter yan, diameter na 10 meters. Wait lang, given, try natin. So, given, okay, you have your given na diameter na 10 meters, and at that diameter your velocity is 900 cm per second. So then after that, as the liquid flows through the pipe, nung nagtuloy-tuloy siya, the velocity of that liquid nag-increase into 2,500. So velocity daw is 2,500 centimeter per second. And we have now our 2 points, which is yung first point na kung saan your diameter is 10 meters and your velocity is 900 centimeter per second. So this will be our point 1, and then your point 2 is when your velocity increases. So this is your point 2, 2,500 centimeter per second. Now what will be our required? Required. So ang sabi, what will be the area? Now ang required is area at that point. So anong point yung tinutukoy na ito ngayon? At that point wherein your velocity increases to 2,500. Now 2,500 centimeter per second, the velocity is 0.2. So your required is area at 0.2. Okay? Okay. Now for the solution. What you will need to do first is to identify what type of flow is this problem. Now, as I've said, incompressible flow is when your velocity is less than 100 meter per second. So this is incompressible. Now, if your velocity is more than 100 meter per second, your flow is compressible. In this problem, you have 900. 900 nga naman is more than 100. Diba? Mas malaki yung 900 kaysa 100. Though, the unit for our considerations is in meters, and the unit here sa problem na to is in centimeters. Therefore, hindi pa natin siya ma-determine unless gawin natin yung centimeter na meter. So, gawin na natin, velocity at point 1 is equals to 900 centimeter per second times, so gawin na natin, your centimeter is 100 centimeter. Again, use your conversion table that I've provided. And 1 meter is equals to 100 centimeter. Therefore, 900 divided by 100 is 9 meter per second. So that same goes with the velocity at 0.225 centimeter per second times 1 meter over 100 centimeter. Magka-cancel si centimeter sa ilalim, so magka-cancel to 2,500 divided by 100 is 25. So we now have the velocity, so we can now identify kung anong type of flow. Now, in this problem, our velocities are less than 100 meter per second. Therefore, this is an incompressible flow. Okay. Now, we have the velocity. We have the velocities at point 1 and point 2. What we need is our area. Dahil ang incompressible flow, continue the equation. Our formula is area 1, velocity 1 is equals to area 2, velocity 2. What we only have is the diameter. Now, analyze the problem. It says here that the liquid flows through a pipe. A pipe is parang ang pipe ay ganyan, diba? Now, here sa pipe na to, sa mga pipe, ang area niya or cross-sectional area niya is a circle. Now, for the area ng pipe, we will need the formula ng area ng circle. So, area ng circle is equal to pi r squared. Tama? And wherein your r or your radius is your radius is equal to diameter over 2, right? So, ang formula for area will be diameter over 2 or diameter over 4 squared. So, that will be our area. Dahil nga r squared, so naging d over 2 squared. So, d squared is d squared, then 2 squared is equals to 4. So, yan. Meron na tayong formula for area at point 1, which is pi d squared over 4. Then, substitute d1, which will be pi over 4 times d squared, which is 100 squared. Therefore, our answer for our area at point 1 will be pi over 4 times 100. 10 squared. 25 pi. So, ang unit neto ay, ito pala, hindi ko nalagay yung unit. So, here, 10 meters. So, meter raised to 2 is meter squared. Yan. So, nandito na yung area at point 1 natin. Meron na rin tayong velocity at point 1. And meron na rin tayong velocity at point 2. As you can see here sa problem, we have area 1, velocity 1, and velocity 2. We can now solve for the area at point 2. So, let's see. So, area at point 2 will be area 1, velocity 1 is equals to area 2, velocity 2. Now, isolate area at point 2. So, the formula will be area 1, velocity 1 over velocity 2. Okay? Dahil nga nilipat natin to dito sa, yan. So, yan. Okay? So, substitute the values. We have 25 pi meter squared times your velocity at point 1, which is 9 meter per second, over velocity at point 2, which is 25 meter per second. So, magka-cancel si meter per second dahil meron sa taas at meron sa baba. Therefore, your area at point 2 is equal to 25 pi. Kita pa yan. 25 pi times 9 over 25. That will be 9 pi. So, area at point 2 is equals to 9 pi. Don't forget the unit. Ang natirang unit is meter squared. So, meter squared. The area for this at point 2 for this problem is 9 pi meters squared. So, next topic. So, our next topic focuses on the incompressible flow. Sa part 2 na yung compressible flow. So, here in incompressible flow, wherein your velocity is less than 100 meter per second, therefore your density is neglected. Now, the important formulas here is first will be the momentum equation. This momentum equation is derived dyan sa page 6 to 7 ng inyong module. And momentum equation or Euler's equation has the formula na change in pressure is equals to negative density times velocity change in velocity. So, dito daw nanggaling yung formula for our Bernoulli's equation. So, nakita dyan yung derivation, and then sa page 8 ng inyong module number 2, makikita na natin yung Bernoulli's equation for incompressible flow. Bernoulli's equation, which is pressure at point 1 plus 1/2 density times velocity at point 1 is squared is equals to pressure at point 2 plus 1/2 ng density times velocity at point 2 squared, wherein P1 and P2 is pressure, V1 and V2 is your velocity, and then your density is isa lang dahil nga bakit incompressible flow siya, your change in density is neglected. So wala tayong density 1 and density 2, same value sila, though hindi sila magka-cancel dahil nga yun nga, nasa isang term lang naman yung density, wala naman tong density, so hindi sila pwede mag-cancel. Makikita nyo naman siya dun sa derivation. So yan. ang ating Bernoulli's equation. Take note that here sa Bernoulli's equation, you can only use this Bernoulli's equation if your flow is inviscid. This is stated here sa inyong module number 2, page 8. Inviscid flow, or what we call a frictionless flow. Hindi natin kino-consider yung friction na nararamdaman ng substance doon sa tube or duct, and then or sa streamline, and then this Bernoulli's equation is not applicable for compressible flow. Again, kaya nga ito binigay for Bernoulli's equation for incompressible flow dahil pang incompressible lang siya. This will not be applied in compressible flow. So, makanalilito kayo. So, bawal siya sa compressible flow. Okay. So, let's try to answer. So, ito yung formula ha. Also stated that Bernoulli's principle, so, ang sabi sa Bernoulli's principle, akong marker, that habits of Bernoulli's principle that as your pressure increases, your velocity will decrease, and vice versa. If your pressure is decreasing, your velocity will increase. Again, like the area and velocity, pressure is therefore inversely proportional to velocity. So, kunyari, nakakuha kayo ng pressure na 180 m at 0.1 yan. Then, your pressure is 1080 m sa 0.2. Also, the velocity at 0.1 mo is 10 meter per second. Then, nung sinolve nyo yung velocity at 0.2, ang nakuha ninyo ay 100 meter per second. Nag-increase yung pressure mo and also nag-increase yung velocity mo. Bawal yun. Dahil nga sabi sa Bernoulli's principle, if your pressure increases, your velocity should be decreasing. Kaya, recheck nyo na yung solution ninyo. May mali siguro kayo sa pag-input ng cycle or doon sa mismong solution ninyo. Kaya dapat ang magiging velocity mo should be less than 10 meter. Should be less than 10 meter per second. Dahil nga nag-increase to, dapat magdi-decrease yung velocity mo. Let's practice this using the example number 1 in your module. So sa page 8, example number 1, we have the problem. Consider an airfoil in a flow of air. So, air. We're far ahead upstream of the airfoil. The pressure, velocity, and density are 2116 pound per feet squared. Then 100 miles per hour and 0.002377 slugs per feet cube respectively. Meaning respectively pagkakasunod. So, sabi dito pressure, velocity, and density. Therefore, respectively, your pressure is 2116, then velocity is 100, and density is 0.002377. So, sunod-sunod. Then, at a given point A on the airfoil, the pressure is 2070 pounds per feet squared. What is the velocity at point A? Now, let's first illustrate. Sabi dito, may figure pero hindi ata sila nakapag-provide. So, let's illustrate the problem. You have an airfoil. You have an airfoil. Okay, then ang sabi, far ahead daw or upstream of the airfoil, meaning far ahead dito. So, nasa unahan ng airfoil, you have your pressure, velocity, and density. Pressure, velocity, and density. Okay? Then, at a given point A on the airfoil, so let's say na ito daw yung point A. Basta at A point, or kahit nandito yung point A, ganyan, ang makuha daw doon sa point A is the pressure, which is 2070 psf. So this is point A. What will be the velocity? So first, ito yung figure, na-analyze natin yung figure, and we will now find the givens. So ano yung mga given natin? First is pressure, velocity, and density at this point, or upstream. Let's say that the upstream is your point 1. So pressure 1 is 2116 pound per feet squared is psf, and then velocity 1 is 100 miles per hour. Let's convert na kahit dito pa lang sa given. So you have your feet, you have your pressure as feet, and you have your density na naka-feet rin. Therefore, even if your unit here sa velocity is in English, dahil nga naka-feet yung pressure mo, and then your density is in feet per cube, feet cube, so kailangan natin siyang i-convert into feet. So, as well as your R. So, dapat ang velocity mo will be feet per second. Therefore, your velocity 100 miles per hour is times mo sa, again, use the conversion table that I've provided. Meron dong miles to feet. So, 1 mile daw is equal to 5 to 80. Ano kung 5 to 80? So, 5 to 80 feet. Also, your seconds to hours to seconds. So 1 hour is equals to 60 minutes, and then 1 minute is equal to 60 seconds. So ang magka-cancel dyan ay miles, dahil may miles ka sa taas, may miles ka sa baba, may hour ka sa taas, may hour ka sa baba, may minute ka sa baba, may minute ka sa taas. Therefore, your velocity at point 1 will be in feet per second. Now, what will be the value? So, 100 times 5 to 80 over 1. So, hindi ko nalalagay over 1 times 1 over 60 times 1 over 60. Therefore, our velocity will be 146.6667. So, take note that even if sa solution pa lang, you should at least include 4 decimal places. So, ayan. Pero much better if you would store this value, shift store A or shift store any variable to, yan. Basta at least 4 decimal places kahit solution pa lang. So, let's put the value here. 146. So, 100 mile per hour is also equal to 146.6667 feet per second. Next, given is the density at point 1 or upstream ng airfoil. So, we have 0.002377 slugs per feet cube. Not necessarily SSLC sila, kasi nga 2116.8. So, our SSLC for pressure is 2116.8, hindi po 2116 lang. So, yan. Also, we have the given for the point A na kung saan our pressure daw is 2070 psf. Now, what we need or the required is the velocity at point A. Okay, what will be our formula? Again, you have your pressure, velocity, and density. the formula will be, let's first analyze if the flow is compressible or incompressible. So again, let's see. In feet per second, your velocity is 146. Okay, now what will be your velocity in meter per second? So simply 146.667 dito na lang times 1 meter is equals to 3.2808 feet, equal siya sa cancel yung feet, 146.6667 divided by 3.2808, that will be 44 lang, 44.7045 or 46 meter per second. Therefore, your velocity is less than 100 meter per second. This problem is in incompressible flow. So, we can use the formula for Bernoulli's equation in incompressible flow, which is P1 plus 1/2 density V1 squared is equals to P2 plus 1/2 density velocity at point 2 squared. Let's say na point A to, itong point A mo is point 2. Point A is also equal to point 2. Pressure A or pressure at point 2. Now, let's see if kompleto tayo. We have your pressure at point 1. Siyempre, 1/2 is a constant value. Then, density mo daw ay 0.002377. And your velocity is 146. Meron rin tayong velocity at point 1. And then, you have your pressure at point 2. And 1/2 is a constant value. And your density, since this is an incompressible flow, therefore your density is the same as your density at point 1. Last, this is the required. Dahil kompleto naman tayo lahat, let's isolate velocity at point 2. So, let's first move this pressure point 2 since naka-addition sila. Kapag nilipat siya sa kabilang equation, this will be pressure 1, then copy nyo lang yung left side, then move the pressure at point 2. So, this will be minus. Dahil naka-addition nga to, magiging minus siya kapag nilipat. 1/2 density velocity squared. Next, let's divide both sides by, kailangan natin i-isolate tong V2. So, let's divide both sides by 1/2 over 1/2 density. So, 1/2 density over 1/2 density magka-cancel dito sa part na to. And then, in this part, 1/1/2 density. So, let's input this. So, first, this one, V2 squared is equals to, kita ba? 1/2 density. 1/1/2 density. Nakakita. So, P1, pagtabihin na natin si P1 and P2 plus 1/2 density V1 squared over your, kasi yung numerator na to, P1 times 1 will be the same. So, ang ilalagay na lang natin is 1/2 density. That will be our formula wherein your squared, para matanggal lang yung squared, and your squared, so para matanggal is square root nyo lang. So, yan. So, your V2 will be square root ng P pressure at point 1 minus pressure at point 2 plus 1/2 ng density times velocity at point 1 squared all over 1/2 ng density. Hindi pwede mag-cancel yung 1/2 ng density dito dahil wala namang 1/2 density dito. Okay? Pwede naman kasi lahat ihiwalay nyo pa sila. So, mas hassle sa paglagay sa cycle. Therefore, let's see. Ito na lang. So, let's apply the formula. Let's substitute the values. Pressure at point 1 mo, 2116 PSF minus pressure at point 2, 270 PSF. Now, plus 1/2 ng density mo is 0. And the times, di ka siya ata, 2377 slugs per feet cube. Then times your velocity 1. Velocity 1 yan. Don't forget the squared, 146.6667 feet per second. Don't forget the squared sa velocity. Then 1/2 ng density na 0.002377 slugs per feet cube. Before we solve na natin pala sa cycle. So, solve na natin sa cycle. So, we have your, let's see, kita ba? Square root. Square root. Yan. Then, lagay na natin yung over. So, fraction. Wherein, sa taas natin is 2116 minus 2070 plus 1/2 is also equals to 0.5, pero pwedeng 0.5, pwedeng 1/2 na rin. Do kasi pag nag 1/2 ka, parang hassle. Well, 1/2 na lang. So, times 0.002377. Don't forget, dalawang 0 yan. Be careful sa pag-input sa cycle. Next is your 146.6667 squared. Don't forget the squared. So 1/2 times over 1/2 times 0.002377. Okay, so let's see what the value will be. Your velocity will be, velocity at point 2 will be 245.3882. So, that is your value. What will be your unit? Siyempre, alam naman natin na yung velocity is feet per second. Pero, paano nangyaring feet per second yan? So, don't forget the formula na nakuha natin. Anyway, you can practice it naman. We have square root ng PSF is pound force over feet squared. Minus PSF is pound force over feet squared plus your, siyempre walang unit ng constant value na 1/2, constant numerical value na 1/2, so plus slugs over feet cube times feet per second squared feet per second squared will be feet squared over second squared. Tama. Okay. So, we all know that pound force is equal to slugs. Pound force is equals to slugs per feet and times feet per second squared. Parang mass times area, diba? Mass times acceleration. So, slugs na taas, feet per second squared. Since may squared dito, we can now cancel one of them. Magiging feet na lang to. Then, ito magiging squared na lang to. Gets ba? So, this slugs feet per second squared is now your pound force. Then, may natira kang feet squared. So, same na sila. So, magiging, saan natin lalagay? Hindi pa natin nalagay ilalim eh. Magiging, ano na to? This will be pound force over feet squared. So, pwede nyo na siyang ipag-add dahil same na sila ng unit. Pound force per feet squared, pound force per feet squared, pound force per feet squared. All over 1/2 na walang unit, and then your density na slugs per feet cube. Ngayon, paano natin gagawin to? So, let's burahin. Huwag na natin burahin yung final answer. So, buksan natin to. Okay. So, we have the ano ba nangyari? Pag pinag-add natin yung same unit, that will be the same. Pound force over feet squared. Tama? Now, divided by the divide mo yung fraction that is the same as times the reciprocal of the fraction times the reciprocal ng slugs per feet cube, so feet cube over slugs. Now, we have feet cube dito sa taas and feet cube sa baba. Therefore, ang matitira, feet. Dahil feet cube over feet squared is feet. So, may feet ka na lang. Then, you have your slugs, wherein your pound force is slugs times feet over second squared times your feet over slugs. Nag-gets pa ba? Nakahabol pa. Okay. Now, we have your slugs. Sa taas may slugs ka sa baba. Magka-cancel. And then, ang natira is feet times feet, which is feet squared over second squared. Now, kapag in-square root mo yung squared, that is the same as, hindi nakita. That will be the same as feet. So, square root ng feet squared is feet, and then square root ng second squared is second. So, this will be your unit sa ganitong formula. Nabura ko na. So, your unit for velocity is feet per second. Feet per second. Our final answer is 245.3882. Pero yung nasa module 2, 245.4 kasi nga i-round up niya. Pero tayo, dapat 4 decimal places. Okay. Medyo mahaba pala yung cancellation. So, yun lang. Kung alam niyo naman yung formula for, yung unit for velocity, you don't have to show it naman na. Pero kung paano lang makasigurado kayo, you can still write it kung paano siya nakuha yung unit. Kasi sa unit mo rin makikita kung tama yung formula na ginamit mo. Okay? So, that's it na pala for part 1. We will now proceed to part 2 sa next video. Okay.